You know, once in a while in engineering, you get those subjects that are just full of words with no calculations, just theory, 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 and you just have to cram. This subject right here is one of them. I've been sitting here since 6. It's now 23, 21, and I'm not confident that I actually know what is going on. I've given up on studying while sitting down, and I've decided to use my standing desk. Hopefully that will work, but seriously though, why do they do this to engineering students? Should this really be what we're doing? So automation is not bad. I can understand why some aspects are there. It is applicable in electrical, but still, this is the type of things you sort of learn or get into, much like common knowledge after doing it for a while, not necessarily cramming and not knowing why you're cramming. I mean, look at this. I'm not sure if you guys can see. Okay, hold on. Let me check quickly. I think you guys can see. Anyway, you've got this whole this is all page 15, 13. You've got this whole thing, all these words. I mean, just look at this, all these words to cram. And by the way, this is just unit 1. There's 6 of them that you have to cram. So it's one of those things. Hopefully my studying desk will help, because right now this is not working. And if you're wondering why I'm in this getup, well, right now it's the 4th of June and winter decided to become very, very cold out of nowhere. So that's why I'm in this getup. But let's hope I can finally start studying. Hopefully I'm in the frame. If I'm not in the frame, then I'm not in the frame. I'm supposed to be studying after all. Okay, so unit 1. Okay, but admittedly, I have been reading. Only problem is that there's a lot of, those, you read, you sort of understand what's happening, but you need to properly understand, know and memorize what's actually written and what's actually said. So that's the problem I am facing. Okay, but there's way too many words. I wonder if I'm actually going to study able to understand. I also decided to play some lo-fi in the background, because apparently that helps with focus and studying. So most of the things that I've tried are not working that normally work. So maybe this will work. Is this a bad time to try it? Probably, but this is what I have. Okay, so here's what I decided to land on, right? I decided to ask myself questions on subject matter in a sense, and then I'd use the thing to refer. So here's an example. I asked, what is automation? I said, a few examples of automation is getting a robot to do something for you, or making a robot do repetitive tasks. And one of the answers I got from the slides was the process whereby a machine is given commands with an automated feedback control to ensure proper execution of the instructions. The resulting system can operate without human intervention and not making a robot do repetitive tasks. So guys, allow me to show you this interesting graph that I found while studying. Still on, let's see, the 8th page of the 75. Well, at least I'm making progress. Anyway, I'm finally understanding what all of this means. Yes, I mean, engineering, we're in the system. Okay, system is not the right word, but anyway, we're in the system of learning the day before the test. We don't revise. We learn the day before the test. Anyway, we've got input transducer, which is an input sensor. You've got a controller, and you've got a processor, and then you got a feedback. And you got this plus, minus, plus, plus. What does that mean? And if you wrote the test with me and you're also saying this, well, I apologize. But anyway, back here. So we've got an input sensor, and then we've got this thing. Then we've got a controller, which is what, let's say, changes the input and outputs. It changes the output to our processor, and then we've got outputs here. Then we've got a feedback. Now, so we've got an input transducer, let's say in a general sense for the first time while it's working. When an input transducer, the input transducer goes to the controller. The controller does the same thing. It just outputs as well to the processor. Now the processor has, let's say now the controller has an output, right? Now let's say that output, there's some disturbances in the environment and so on. That's why here it's a plus. So you get a plus, you've got some disturbances. That disturbances now gets exported. Get right here, man. That's not the right word as well, but anyway, that gets exported into your output signal. So that means, for an example, let's say you have let's say you have a controller, right? Now that controller has I'm gonna use current. Another controller has a current of, it outputs a current of say 15 milliamps anyway. We've got 50 milliamps. It outputs a current. This is the reason I'm gonna put it down. So we've got a current, right? It inputs a current. No man. It outputs a current of 15 milliamps, right? Now you've got some, let's say now disturbances from the external environment. You've got some disturbances. Those disturbances now input say 1 or 2 milliamp. Let me check if I'm recording actually. Yes, seems I am. I'm studying with YouTube, because if I studied normally, I would not study or understand. Back to what I was saying, you've got an output of signal of 50 milliamps, let's say, and then you've got say 2 amps of disturbance. So you want an output of 50 milliamps, but then you've got a disturbance of 2 milliamps. Now your output is 17 milliamps. Simple math. Now, so you've got an output, right? Now you've got a feedback element. Well, that feedback element, right, it takes your output signal, and then that output goes to the feedback element. Now your feedback element checks how much is, what's the difference between the input that it gets and the output. What's the difference between the input and the output? And then that gets sent to your summing junction. Now you've got, so once back again, now you've got the signal running in, let's say for the second time, you've got an input transducer releasing, and then it's the input sensor minus the feedback. Now why is it minus? So let's say here you've got a 17, right? Actually, wait, does this make sense? Okay, it should it? Okay, yes. Anyway, the way I understand it, right? You've got your input transducer is releasing an output of 15 milliamps. Now this is very painful. Now you've got an input transducer releasing 15 milliamps, and then you've got a feedback. In this case, let's say your feedback is, suppose there's two ways you can do this, but let's just say in this case your feedback is checking your input and your output. So your feedback, your input say was 15, output was 17. Now you've got 2 milliamps right there, and then you've got, so what you have then is 15 minus 2, which gives you 13, which is less, right? But then you've got a 13, so you've got 30 milliamps. Now your disturbance, remember, is 2 milliamps. So you've got 13 plus the 2 milliamps, and you've got 50 milliamps, which is what you want. Now let's say your disturbance changes again from, let's say, 2 milliamps to now 4 milliamps. So you've got 13 coming in. Now 13, instead of 2, it's 4, because that gives you 17. That now gets back into your feedback element. Your feedback says like, whoa, okay, this is now a difference. Now we're back to 17 instead of 15, so the feedback is going to change to, let's say, 4 in this case, because the difference between the input and the output. My input in this case is 13, my output is 17, so it's going to say 4. Now it's going to say 13. No. Okay, let's just say my input is 15, then I want to controller was 7 plus 13, so now it's 15. Feedback is 4, so feedback, that's 15 minus 4, that becomes 11. 11 gets through. This is the problem with wearing gloves. Now, so input is 15, feedback is minus 4. So you got 15 minus 4 into your controller says 11. So 11 plus 4 disturbance, that gives you what you call 15. Does it? Yes, it does. 11 plus 4, that gives you 15. That's the output signal. And this is our control feedback loops on page 8. Now I've got another interesting thing to show you. So we've got this graph over here. We've got programming automation, flexible automation, fixed automation. You've got a production quantity and a production variety. Basically, the more variety you have, okay, let's think about a production plant, right? And say, in this case, we're producing car doors, for example. So in our car doors, the more, let's say, now if car doors is the one thing we're producing, right? Meaning that our product variety is low, which is just one, because we're just producing one car. We're just producing one thing, which is a car door. That means we can have much higher production quantity on that plant, because then now you're producing, let's say, 1 million car doors instead of one, because you have one thing, that one machine does one thing, which is where fixed automation comes in. Fixed automation is just automation in the sense of everything is fixed in the thing, everything is fixed in the plant. You're not moving anything, there's no product variety or any changes to the automation. You just program it once and then that's what you get. So it's fixed automation. Now say we were to add car doors and car windows. These are bad examples, but anyway, you've got car doors and you've got car windows. Now we've got a much more production variety, meaning now there's two separate machines. Now we've got two different types of machines creating our production. Wait, you've got two different types of machines that are working to produce the quantity that you have. So you've got car doors and you've got car windows. That means now on your production plan there's less space to just make 1 million, and in this case your production quantity now goes down to 10,000. Now flexible automation, what that means is that so let's say now your machines are programmed to just create one type of thing, which was a car door, but now you program it to now use Windows now to create windows, which thinking about it, like I said, it's a bad example because those two don't switch, but that's what we're working with for now. So you program from car doors to windows now, but it's flexible in the sense that you can create this and then after that create something else. But in your production plant, you don't have that much. Your capacity now is split between your car doors and your car windows, which is why your production quantity goes down. And lastly, we've got programmable automation. Programmable automation meaning that your machines can do a variety of things. Car doors, car windows. How am I running out of examples for car things to make? And I literally have a car image in my mind. But anyway, you've got car engine parts, you've got car flywheels, you've got car doors, car windows, car bonnets, etc. You can program your machines to do a lot of things. So that's what it means by programmable automation. You can move in between many different things, which is why now your product quantity is low. Product variety though is high because you're doing many things. With a fixed automation, what you've got is that you've got a high production cost because you're using a lot of machines to set up and to batch and to create to create 1 million products. Flexible is now on the medium product cost variety because you're making less products, and then programmable is a lower cost compared to your compared to fixed automation, because you're batch producing, you're not producing everything just once. So normally when you use a fixed automation is where let's say you're producing car doors, you want to create something. This plant will create car doors forever, whereas in your fixed, it's creating a few different things, but it's not just one thing set on this. So you're not, as someone designing the plant or someone who's using the things in the plant, you're just designing to not perhaps fully use it full time. And then for programmable, now you're just batch producing. This plant is not made for a specific thing. This plant is not made for a specific thing. It's made for many different things. So finally my hand gets some rest. It's not made for a specific thing. So that's what programmable is, which is why it's also lower cost. And those were my notes on page 19 of Unit 1. I should get back. That is automation in a nutshell. Oh my word. And here I was about to start, and then you've got all these 10 things that I have to, well, it's 9, and some more. Let me just get back. By the way, this lo-fi music is actually helping, because when I try to study with no music, silence, okay. So generally my workflow is to work with music on, but it's different genres of music, where generally I'm able to focus, but then today I couldn't. My mind was all over the place, business and so on. So I went with no silence, and that didn't help. Sometimes I took breaks to think about business. Sometimes I just took breaks to just clear my mind and then try a bit of automation again and then go back to that. So, but now when I'm doing this lo-fi, it's actually working pretty well. I'm just in the moment and studying. Chances are those also probably because there's a time limit and I need to sleep since I'm writing very soon. But you should try it out. This lo-fi is really working well, I would say. Link in the description below. Getting very hot. I ended up giving up on the theory part because I honestly speaking was not going to finish, and just decided to work on the previous test and exams that we have, so that I actually know which part of the theory to work with and so on. Little side note though, if you want to get active, moving, healthy, whatever, get yourself a standing desk. It's an easy way to get yourself moving. When it comes to say standing, you get used to standing and so on. But movement wise, you just move. You move in times when you're not expecting to move, you just move and walk up and down. Sometimes you find me walking up and down this hall. It just happens. Right now I took off the blanket because I'm warming myself. So even if I'm cold, because I'm standing, I can easily move around. So that's easily warming myself, and those are some of the benefits of standing desk. Suppose if you're sitting down during exam season, getting cramped. A standing desk really helps. So little side note on standing desk. But back to the content. Calculations, which I also do not like for some reason. I don't know why I'm doing engineering, but I also do not like calculation. Not do I like the theory. I like understanding the theory, but not cramming the theory or doing the calculations. I just like understanding things. I must say, calculations are a bit lonely without music, or just very, very, very quiet, way too quiet. Ever since I got a calculator like this, I never wanted to switch it back to that great calculator. Let me find it. Wherever it is. Well, I can't find it, so either I lost it or I threw it away. But anyway, ever since I bought this one, it has so many more features. I'll just put a picture up there so you guys know which calculator I'm talking about, the one that I had. The ones we use in high school that everyone knows. But this one, it's a much better upgrade with more features and so on. It's just much nicer to use. Only I'm not taking off my gloves for this though. It is very cold. Well, not so cold since I'm moving around, but my hands are freezing. 5 divided by 1 million. Why are we doing calculations like this? How am I supposed to find 5 times? Okay, wait. Finally! 1/2. So here's our track limit. So you've got that, you've got equal to. Okay, so you get a normal answer like that. Fair enough. What's the problem? Don't just hate it when calculators do this. You're using a calculator to not calculate. Now you get an answer like this, and then you have to calculate. What if now you get your decimals wrong? I suppose it's part of the job. But anyway, that's not what's supposed to happen. I'm supposed to get 0,0. Supposed to tell me how many zeros I'm getting. Instead of giving me 5 times 10 to the power of minus 6. And now I have to calculate something else. I know how to calculate it, hopefully. But still. Basically, if you get 5 times 10 to the power minus 6, you should have a 0, a comma, 5 zeros, and then the 6th number should be the 5. Funny enough, I'm not noticing this music. It just happens once in a while, and I notice that it's there. But most of the time, it's just fading into the environment, which is weird. Though, the inspiration for this, though, was from an answer in progress video, which I have been binge watching lately in my no visual saga that basically, what I was replacing is now replaced by YouTube, and on YouTube, it's answer in progress. I'm kind of in the same place, but I'm not. Anyway, link is up there in the card, and highly recommend that you watch them. Wait, what am I doing? 30. This is 10. Not what did I do wrong? How many zeros? 1, 2, 3, 4, 5. 250. Did I calculate right? PID. Why? Conjure, what's that other one? You gotta feel open, you gotta feel closed, you gotta feel. Feel what? Okay, 4th IR, as you all know, it is the 4th internet revolution, which basically means we had 4 internets before the internet we have now, which of course is false. The 4th industrial revolution, because we've had 4 different industries before now. If you ask me to name those industries, I have no idea. I suppose I do. It was there in the notes. We've got the steam engine, first industrial revolution, and then we've got factories, the second industrial, and the third unnoticed, which I think most people forget about, was computers, and then the 4th we've got AI. Video coming on AI. I was about to say soon, but it's not coming soon. But it's coming. It's coming in September, July, maybe. We're doing June. September. Probably. If not September. What's after September? Wait, you got August. Okay, it's coming in August or September. One of those. Anyway, 4th IR means Fourth industrial revolution. And for these next questions, I have no idea what they are. Automated factory system, you can finish vision systems. Unfinished junior vision systems. You've got power supplies, you've got programmable logic controllers, servo driver systems, inverters, relays, and timers. Wait, what's the question? Programmable logic controllers, it is to, I have no idea. Servo driver, I have no idea. Inverters, I have no idea. Relay, I don't know. Timer is to time. Let's see what the memo says. Inverter to generate AC power from DC power electrically. Check out the rundown we're releasing soon. We talked about Edison and Tesla, the inventors of AC and DC, and how Edison, to prove that AC was not harmless, he electrocuted an elephant. All of that in the rundown episode dropping this Saturday. Today is Wednesday, so hopefully if I drop this on Thursday or today, that episode is coming on Saturday. When I the first test done and the 11th test to go, when am I going to finish? What time is it? What time is it? It's 1. Doesn't look like I'm going to finish anytime soon. 15, 18. Okay. Minor load shedding happened. You don't know that. What? Wait. Don't do that. Solution. Right. So it turns out even Trevor is having problems. Asking him, this is still automation, or we're doing English paper 2 literature. Even me at this point, I'm recording a YouTube video while studying because it's not going well. You'll see it tomorrow. I'll release it tomorrow or today. That's the only way I'm able to start and record. If I record a YouTube video, it will be released tomorrow. So it turns out even Trevor is fighting with automation at 1 p.m. AM on the 5th of June when we're writing 8:45. Okay. Vision system. What is a vision system? Hey, is here again. Okay, so what is a vision system? I forgot. PLC, I forgot. It's a servo driver. It moves, rotates, and processes based with high speed and accuracy. You got an inverter. You got an inverter which provides AC current, right? Your relays and your switches. That is probably wrong. This is 7 marks again. You got your relay and your timer. Now, your relay, it provides an output based on the input. Based on input it gets. The timer, same thing, provides an output based on input it gets after a given time delay. If I now use your energy via standing disk, like I said, you move for no reason. But now at least I study. If I said that, I was not going to study at all. Which is weird, because generally what generally happens is that I'll sit down for days at a time. So let's say on Monday I sit down, and then I work. And you got Tuesday, same thing. Wednesday, same thing. And then by Wednesday I can feel my lower back has some pain. And that's generally what happens and how I know that I've been sitting down for too long. Whereas for now, I sat down and I didn't get those signals. Probably because my body was tired. We won't explain all these movements that I've been doing. But not tired. But I was somewhat doing some things, exercising, playing basketball, which will be released very soon. So subscribe. But probably why I didn't realize that I needed to stand up and things. But I would say things are getting in. I just have 9 tests to go.
A few moments later.
We're here with 9 tests to go. I'm not even done with this one. I'm only halfway. Page 6 of 12.
Arrest this man.
The questions are repeating. Now, memo, vision. You have to measure the figure or dimension of an object and compare the given target. You pass the signal to them. Also, price is apparent control device. And the machine doesn't mean time. Output device according to the signal and the input devices. Yeah. So, move rotate the process, target product with more high speed. And like I said, inverter generate alternating power from DC current. Why? Just use DC. It's simple. Okay, so vision is to measure the figure or dimension of the target product based on the PLC is to operate the output of the target product based on the input signal. Yes. And then you've got servos to move, rotate, and process the target product. Huh? No. High speed and accuracy. Relay to operate an output of the target product. Oh. If you guys are interested in what I'm listening to, just checking it out, which is the peaceful piano. Well, if you guys can hear what I'm playing. Anyway, it is the peaceful piano radio music to focus and study to. It's really, really helping. So yeah, that's what I'm listening to or playing in the background. It's pretty nice, I must say. Reminding me of a few songs that I can't play because of copyright, but I'm not actually quite sure if this one will be copyrighted as well as I spend my time here instead of studying. Anyway. You gotta normally open push start release. You gotta normally close push release stop after 20 counts. Okay, I got my start and my stop. That's a SR. Where do you go? So I got a counter. I got a C. I got a. What else do I have? I got a counter. I got the reset and I got the preset value and I got the preset value straight. I got a current value and I got a Q. Watts. I got a Q. Watts. You got a motor that goes on and you got a CPU, you got a 20. These guys don't know what I'm talking about. I'll put the diagram here so that you know what I'm trying to figure out. Anyway, you got a reset which you reset, and then you got a 20. What is the name? I'm studying. Kind of. The automation pyramid, they classify the different IT layers of industrial automated production plants into 5 layers. In a chronological order, show these 5 layers from the top layer to the bottom layer and give an example of typical associated systems or equipment on the lowest plant layer level for a total of 6 months. For what reason? We do not know. Right, so you got a management. You got a management at the top. Then you got a supervisor, you got a control, you got a field. What am I missing in word triangle? So you got your field, you got your control, you got your supervisor, you got your management. I am missing something. And you got your planning. Okay. What? So you got your management, yeah. You got your management, and then you got planning. Why is planning there? Then you got your supervisory. So you got your management, you got your supervisory, then you got why is planning there? You got your management, you got your planning, you got your supervising, you got your control. Which also doesn't make sense. Why the heck is control under supervisory? Okay, I suppose it doesn't make sense. Then you got your control. After control, you got your field. And in your field, you got your sensors and your actuators. What's an actuator? I have no idea. And it's in the test. So you got your management, you got your planning, MSE. Why it's there? Nobody knows. Then you got your supervisory level, number 3, right there in the middle. Then you got your control. To explain why control is there, because your control, wow. Remember that diagram that I was drawing for 5 hours and going back and forth with the sum and not what I'll put the picture. So that one day is your control to check if there's no errors between what you want to get on the output and what you're getting on your input. That's your control. So you got your field at the bottom, you got your control, you got your supervisory, you got your planning, and last but not least, the C-suites. You got your management. Where is this here? Question 6. You got industrial and you got conventional networks. Yeah, this is torture. Why the heck am I supposed to know that the round rectangle of an industrial network is supposed to be 250 microseconds to 10 milliseconds. By the way, that's very fast. And why is a conventional network 50 milliseconds? But okay, that makes sense. But still, you know what? Let's do that, please. If you can't see, you can't see. It's not my problem. And then you got the reliability required here is high. The reason why it's high, I'm not going to get into that. And then conventional is moderate. Round trip times 250 US, that's microseconds, to 10 milliseconds. Whereas for conventional, it is 50 milliseconds. Operating environment, hostile hostile conditions. Imagine, hostile is something. Anyway, you got hostile conditions in conventional, you got clean in that. Also doesn't make sense. These words need to be changed, but I'm not the one who made them, and I'm not going to touch. Finally, we're done. What time is it? Almost. Okay. There's progress. There's progress. Right. This is Unit 6 content. I know because I read yesterday, and apparently something is got in. Or maybe nothing got in, it's only getting in today. Because of this music. Check out the lo-fi girl. Very, very helpful. Now, application domain. Conventional network, it is corporate home environments. Environments, yes. The application domain of an industrial network is drum roll, please. I forgot.
No, it's not.
Arrest this man. In a conventional network, why the heck is it called a conventional network? Like, what is a conventional network? What is a hostile environment doing in industrial plant? Hostile, not dirty or anything less severe. Hostile. I mean, they said clean. At least put dirty. I mean, you put clean there. Not hostile anyway. To show you that this is what it actually looks like. Application domain is actually, I forgot. What are the 4 main parts broadly associated with the Industrial IoT field? Now, what the IoT field is the Internet of Things. The Internet of Things. That's for why things of internet. I really do not know. But that is associated with the 4th internet revolution, as I told you guys. 4 main parts. I honestly speaking do not know the answer for that. Intelligent assets, a data communications infrastructure, analytics and application to interpret and act on data and people. Okay. So explanation time. You got intelligent assets, data communication infrastructure, analytics and application to interpret and act on the data. And you need people. So it's like this. It's like this. Let me break it down. You got things. Right? That are intelligent. Why would an inanimate object be intelligent? Well, it's intelligent when it has internet connectivity baked into it, like your smartphone. They say it's smart, Mara. Anyway, that's intelligent assets or things, right? And then for that, so you need intelligent assets which connect to the internet, having their own IP addresses. So like your blinders. This way you had smart blinders, right? You were that rich, you had blinders, right? You could just click and it open themselves and they close themselves. You'd say it is intelligent, right? So that is an intelligent thing on assets, much like, well, you know what okay, we probably don't. You got, let's say, intelligent blinders that open and close. You know, a smart home, right? That's what I'm getting to. So smart home has their own things. So all those things open and close and so on. That's part of automation. Now they have their own IP addresses. They connect to their own local area network, which is LAN in the home, connected to that one thing. That one thing could be an app on a device. What is the paper doing in here? Apparently no paper, right? So that is your intelligent assets, which all have their own IP addresses, right? So those are that's your intelligent assets. Now they have their own IP address. They need data communication. Tell it when to open and close. Pandas in this case, tell it when to open and tell it when to close. That's when you need data communications network. So you have things scattered. This is going to be a pain to edit. You have things scattered all over, and then you need a data communications network, connecting that. That's the communications network, sort of your local area network, right? So you've got that, and then now you need an application. Now you need the people to see what's happening and how they see it. You need an application to interpret or understand what is going on. Why are they using that difficult English? To interpret, understand what is going on, and analyze. I can't break that one down. If you know, you know. If you don't know, then you don't know. To interpret and to analyze what is going on. See, makes sense? That's the IoT. You need intelligent assets, your blinders, and everything that constitutes, and I suppose I'm also using difficult words. Anyway, you got your blinders and anything that constitutes your smart home, and then you got your data communications, which is your local area network. Well, I'm guessing it's a local area network. I really do not know, but that's your data communications thingy. And then you got application to interpret and analyze the information you're given, and then last but not least, you need the people. Yeah. Oh, data communications infrastructure. Why? Data communications infrastructure. Come on. I mean, intelligence assets. Doesn't that make you think of spy movies? Not this IoT thing that I'm busy with. Make you think of the CIA. You know? KGB. You know? And I'm sure you guys don't know the others. Like your Mossad. And I don't know the others. Well, I know I forgot their names. But yeah, you got your CIA, KGB. So intelligent assets makes you think of not IoT. I mean, come on. I mean, infrastructure. See. I'm in the mocking. See? Third one. See? What I started with is here. Placed within the domain. 7 marks. 7 marks guaranteed, Chief. 7 marks. We're moving. DPMO. 6 Sigma. Right. You got 120. You got 120 production stages. You got 96. You got 17. 96 plus 17. And then the calculator. And then my work disappears. Let's see. 1, 2, 3. 1, 2, 3. You go to equal sign. Then you get this. That's an electrical switch, pneumatic switch. That's a pump. Level switch low. What's a chemical reactor? We even deals with chemicals, never mind. Let me keep quiet. Chemical reactor, before I say something very dumb. A chemical reactor is an enclosed volume in which a chemical reaction takes place. I didn't know that. I was about to shout, but I didn't know that. I thought they were like, those bombs and so on, much like a nuclear reactor, so on and so on. I didn't know that. In an automation company, a process and instrumentation diagram. There's a difference between horizontal and vertical integration in the manufacturing environments. But the goal is the same with transmission of information between various systems and across all processes using data transfer standards and creating the basis for an automated supply and value chain. Depict in a detailed diagram the integration of all the different vertical and horizontal components to be found in an automated factory from supplier to customer. Yes, that is what we do here. Yes. Each is about 30 minutes. got 30 minutes. You got 30 minutes. The clock starts now. There's a difference between horizontal integration and vertical integration into manufacturing environments. But the goal is the same with transition. What am I reading? There's a difference between horizontal and vertical. Retake. There's a difference between horizontal and vertical integration in the manufacturing environments. But the goal is the same with transmission of information between various systems and across all processes using data transfer standards and creating the basis for an automated supply and value chain. Depict in a detailed diagram the integration of all the different vertical and horizontal components to be found in an automated factory from supplier to customer. Yes. Yes, that is what we do here. Yes. You see, this makes no sense. What? The difference between horizontal and vertical integration in a manufacturing environment. Sure, the goal is the same with transmission of information. The goal is the same with transmission of information between various systems and across all processes. What? The goal is the same with transmission of information between various systems and across all processes, using data transfer standards and creating the basis of automated supply and value chain. You got management. There's no planning this time. You got management. You got supervisory. You got control. And then you got the field. Now, in the field, what happened? In the field, you got your sensors. No. You got your pre-processing. You got your processing. You got your analyzation. Then you go to output. Now, in your control is where you got your customers and your suppliers. Yes. Wait. 1, 2, 3, 4, 5. Why are they 5? Why are they 5? Why? Okay, you got horizontal integration. Okay, so you got your field level. You got your pre-process, no? You got your pre-processing, you got your assembly. Wait, do you have pre-processing? When does the processing happen if you got your pre-processing? That doesn't make sense. You got your pre-processing, you got your pre-assembly. When the processing happens, nobody knows, even me, I don't know. You got your pre-processing, you got your pre-assembly, you got your assembly. After your assembly, you got your inspection. You must inspect the product, you see. Make sure that it's working properly. After that, you got your packaging. Make sure it's packaged correctly. But if you're doing a YouTube video, this is a word of warning. You package first. I don't know how you'll do it, but you package first with your title and your thumbnail. So I suppose I should do that for this video. But anyway, if you're doing YouTube, you package first. Yeah, package first. Anyway, you got pre-processing. When processing happens, we don't know. You got your pre-assembly. You got your assembly. And then you got inspection. Yeah, you must inspect the product to make sure everything is good, everything is nice. Must be nice. Nice. Yes. And then last but not least, you package. Not in YouTube, but everywhere else, you package last because you have a proper product, proper inspection. So that is your horizontal integration. No, it's not. That's just on the field level what happens. This is your field level what happens. And then we go up to your control level. And you see on your control level, you got your smart sourcing and your smart distribution. And in the middle, I also don't know. In the middle, there's nothing written here. So what am I supposed to write? There's nothing written here. And you got your smart sourcing from your suppliers to an empty factory to your consumers, where the inspection, the pre-processing, we don't know where the processing happens. Apparently, even on the control level, is not there. There's a lot going on this side. Anyway, you got your pre-processing, you got your no, we passed that one. You got your smart sourcing, your smart distribution. Now your smart sourcing, what you're doing, you're connecting with the supplier. Supplier must give you what you want. You put in your empty factory, you take from the empty factory, give to the customer. No inspection, none of that. Yeah, is what the thing is saying. It's not me, it's what the thing is saying. That's what they pay. And then you distribute to your customers and your warehouse. Isn't the warehouse supposed to be under control? Anyway, you take that, and then that is your field level. That is your horizontal integration. You go to vertical integration at the bottom, pointing up. And then from there, you got your pre-assembly. From pre-assembly is going into an empty factory in your control level. From the control level, you move to operations. This thing doesn't make sense.
What?
You got your pre-processing, you got your pre-assembly. Processing, it disappears. You don't know what happens. Then you got your assembly, you got your inspection to make sure everything is nice like mayonnaise. And then you got your planning, Planning? And then you got your packaging.
And then the ships. Now, you got your pre-assembly. Your pre-assembly goes to your empty warehouse. Look, there's nothing here. And then you got your control level. And you got your process management. And then smart sourcing, your suppliers. Smart distribution, your warehouse. Like I said, doesn't make sense. Why is the warehouse here? But we move. Then you go to customer. Then from there, you go to control level. You go to process management level. You go to operations management level. Where you use Wi-Fi. Why aren't you using Wi-Fi here? I mean, you're doing automation. Everything was connected. Like they said, 4IR, fourth industrial revolution. Internet of things. But I'm using Wi-Fi only at the top. At the operations management level. You don't know that. And then you get, last but not least, you go to an empty box. So what is an empty box? It's a corporate executive management level. Man, it's an empty box. You see the notes I'm studying. They don't make sense. And then you got the real-time KPI. What is KPI? KPI is something. I forgot it, but it's something. You got KPI and then you got customer-specific configuration of product. Is that supposed to happen in the...
There's a lot going on.
You see, university, right? We don't buy, we don't need separate books for every... you see, for every subject, we don't need our own book for each subject. If you want to make each subject have its own book, or I suppose I should say each module have its own book, what you must do, that's for you, that's your own choice to buy that many books. But sometimes you are tight on the money when you are in a university, right? So what you end up doing is that use one book for many modules, right? And that is why sometimes time-saving hack that some of us people that we use in some of us students in university, what we use, this is my time doing this. I spent like 1 minute not getting to the point when I'm supposed to be here. You see, what we do to save some of the space in our books, we do something like this. Ignore the handwriting, but you see, we've got this space. We just underline like that. And then we've got an extra space that we do not have. And another example of that, you see, something like this. Now, all the paper that you paid for, all that money is working hard. Ignore the space right here, isn't there? But you see, all the paper is being used to something effective. You see, so that's a one-time saving hack that some of us will use in university. To save, to make that money stretch. Some people, they say that they want money to be stretched. So that is one of the time-saving hacks. What am I doing? This thing is annoying. Subscribe to the fine girl. Very nice. Because my energy is finished, Anyway, I should just get a job. Anyway, that's my anyway job. I'll make a lot of money. Then I'll have a lot of coins. So many zeros. 1 minus. The tip to enjoy studying is to enjoy yourself first. If you enjoy yourself, you won't have a problem. And buy studying desk. Not sponsored. But I don't have subscribers. Subscribe. Key method. quality control method employed in parallel to a production line clearly indicate. Oh, in parallel. Okay. I remember this one. Yeah, you remember my tip, guys. For students, that's school like that. Simple. Now you got space there, you got space there. This space, maybe we use it, maybe we don't, but we got space there. You see, effective use of the page, of the page. SQC. I don't have space. Okay. I don't have space to draw there or draw there for what I want to draw, so I'm gonna draw it here. But anyway, you got SQC. You've got you got a box there. You got another box there. I think no, you don't get a box there. You got this. You got that. You got that. And then actually, wait, you actually have that. That goes there. You got statistical SQC. You get that. You verify. You get that. You get that. You get that. And then this is you identify the causes. And then I forgot. And then you verify. I've also forgot. This is SQC. 1, 2, 3, 4. 4 marks, ne? 4 marks. Determine the Six Sigma level. Yeah, you see now when we're doing calculations, I can use this space. Turns out this one I'm not gonna use. But if you want to use it, just for some coloring. When I'm bored, just color. For no reason, just color. You can do that. Wanted to color in a lecture room when the lecture is boring you. You just want to sleep, want to live. You just color these empty spaces in your notebook. If it doesn't work, I am not responsible. I'm not responsible for any wasted space on your pages due to drawing. The main objective of a statistical quality control is to achieve quality in the production and service organizations through the use of adequate statistical techniques. Answer the following 2 questions related to statistical quality control with the aid of a blah. Makes no sense. Basically, it is nonsense. I forgot. Right. Successful implementation of the Six Sigma level. What will result in the total production 99.9997% as perfect as it can be, or rather 3.4 per 1 million opportunities. Tell me that isn't a perfect, because I know that it is perfection. That is Six Sigma level. In case you were wondering, like I said, I'm studying on YouTube, because otherwise I will study no more. Regardless, let's get back. Find a new word. I'm not using anywhere anymore. I'm using regardless. Apparently, irregardless is a word. Comment down below on what you think. Imagine irregardless, but regardless, but irregardless. No. I mean, it's a double negative. Why are you using irregardless? Just use regardless. Moving forward. It's 2:57. Okay. So you identify. This pen likes falling. Don't know why. Perfection. 2 Sigma level. You know that study tip. Sometimes you will write the wrong answers. Not because you didn't study, but because you didn't sleep. Sometimes you must strike a balance. Which is why it's 3 now and I'm about to sleep. I'm just gonna finish this test. And then I'm out. Why? It is 4 degrees Celsius. The temperature where water melts. Not 0 degrees, people. It's 4 degrees. If you're outside in nature, right? Outside, right? There in the northern hemispheres. Yeah, my globe that I didn't use for my 12th episode. Link in description when it releases. So you see here in the north parts where there's snow, you see the ice. What the ice does, what the water does, right? What the water does, that you have a, let's take this space of air is water, right? Now what the water does is the first top level is going to be ice, but the rest of it is going to be water. Now that ice happens at 4 degrees Celsius, which is why the temperature where water melts. Yes, temperature water melts 4 degrees Celsius. That's when the top layer of water ice. Then the rest of it doesn't ice. You know why? I read your physics piece in grade 12. Can't tell you everything. But yeah, it ice, and that's why your fishes are able to be alive. That's why you never get an ice block of fish. That would be funny though. But anyway, that's why you don't get an ice block of fish in the veg market. As for why a veg market is selling fish, I also do not know. But that is why you don't get an ice block of fish being sold. You see, the fish is normal and then it's frozen. That's a normal fish. I also don't know. But the fish is caught and then it is placed in ice. You don't get an ice block and in that ice block you get fish. No, that is because the top layer freezes at 4 degrees Celsius. So at 4 degrees Celsius, 3 o'clock in the morning, water is freezing. I don't know when, but it's freezing in your freezer. Anyway, what I also want to show you is the OS. No, I don't want to show you that. But you have the OSI module. IT students. Yeah, the fellow IT students, they know what I'm talking about. OSI level, you got your presentation at the top, you got your application, and then you got your basic sensor. No, you got your session, you got your transport, you got your data. Last but not least, I forgot the last one. Transmission. Is transmission? Network here. Apparently it was network. OSI layer. OSI. No, I'm not gonna explain this. No. Basically, it's in IT. You got your 7 layers: presentation, application, session, transport, data. Layer 2, physical. What the heck is physical doing here? Anyway, you got your application. You got your application, you got your presentation, you got your session, you got your transport, you got your network, you got your totally given your physical. Okay, so first of all, you got your physical layer. I said I was not going to explain what I'm explaining, but anyway, you got your physical layer. In your physical layer, you got the physical connections and the physical lines, the mechanical and electrical connections, the transmit raw bit data stream, raw data moving from one place to another. That's your physical connection. I transfer 1 bit, you transfer me 1 bit. That's your physical connection. Second, your data link connection. And your data link connection, it establishes a data packet structure, framing, error detection, bus arbitration. What does that mean? In the physical, I'm getting. Now wait. In the OSI, top layers are built off of the bottom layers, right? As said here, every layer supports a protocol independent of other layers. Now, a protocol is a set of rules on how something works. Learn that in detail in grade 12, 2022. Right. Every layer supports a protocol independently of the other layers. Every layer product is services to the layer immediately above it. And then you got every layer requires the services of the layer immediately below it. Yes. And then layer 1 is the communication medium, electrical and mechanical connections. And layer 7 is provide the services to the user or an application. Right. And then OSI is an open system interconnection module created by the International Standards Organization. We'll get into that in another video. which is published standard ISO 7498 to provide a common basis for all computer network descriptions. Really? Huh. Anyway. Regardless. Now, the first layer is the physical layer, which is the mechanical and electrical connection that transmits raw bit data. Let's get technical. We put some embedded, we put some digital, we put some software, right? Some IT, right? So you got your mechanical electrical connection and put some electrical as well. So you got the connections in between the wires and then raw bit stream. What is a raw bit stream? That's sending the ones and zeros because, as everyone knows, computers speak in binary or machine code, which is ones and zeros. So that is your physical. Now, your data link. What is data link? What is the established data packet structure, framing, and error detection or pass? Arbitration. I'll put this thing here so that you can follow along. So you got the data link. What is the data link? Now you got data packet. Data packet is a bit of So we have two computers. So computer 1, computer 2. Now computer here send message. Now sends a bit of data. So from 010101, let's say it's a byte. A byte is 8 bits. So yeah, they said 8 bits. That's connection with something to me. That is transmit, receiver, handshake, such as the TCP protocol. So I transmit data, you transmit the data. That is a data packet. So data packet is a packet of data. Why am I explaining? Now you got that. You got framing. I have no idea what framing is. You got error detection, which is a parity checking, which is to check if there's no errors in the data that you're sending. Let's say one of them is corrupted, one of the bits you're sending is corrupted, etc. That is error checking. And then bus arbitration, I am guessing that means that you've got 1, 2, 3 computers, you've got a main thing. Now what the bus is, it connects to everything, so they all speak to each other. Yeah, I'm just skimming through things. And then you got network. So you got your physical data link network. In the network, what you've got then, you've got end-to-end routing and resolving network addresses. Now, what is routing of packets? Routing is sending. So, with the data packets that you get, so from physical to data link, you're moving from electrical connection and you're moving to a data link where you're connecting things and sending much more. You're not just sending raw bits, you're sending data packets that mean something. Yeah. Comment don't move me to go deeper into this subject. And yeah. And then you got data link, you got a physical data link. Now you got your network. Network is the end-to-end routing of packets. So now sending and receiving actual communication in between them and resolving network addresses. So in a local area network, so we've got this thing where it's got 8 billion users, and let's say each person has a device. You've got 8 billion devices now that each connected, that each have to have their own IP addresses. That's a lot of numbers. So to solve that, you've got a local area network now. Each local area now, the local area below, you got your router. That router connects to the main internet. And that connects to the main internet, and you got your local area network. As for why I'm explaining this at 3 p.m., nobody knows. But you got your main area network, you got your main internet there, you got your local area. Now you got many sub-computers there. Now another local area network that does help you is to resolve. Now each one can have, let's say there's this local area network, there's another local area network. Now these two can have the same IP addresses because they don't connect with each other. Right? Like using the same variable in two different functions. They won't create problems because they're not related to each other. Because they're local variables. Now, you got that, you got that. That's how you also resolve networking addresses. I'm guessing in this case means that you're setting up the network addresses for each of the different devices. That's network transport. You're providing network independent, transparent, and message transfer. So you're just transferring using TCP and IP, because if it is transparent, you get hackers now that are able to get into your network, see what's happening, hack into your devices, access information, and yeah. Then you got your session, login session. So you log in, you do your things, you log out. That's a session. So Yeah, connection management services for the application. You log in, you do your things, you log out. That's the session. And yeah, presentation. I mean, come on, it's presentation. Presentation to convert application data from network and local machine formats. Oh, that's different. So you got different file formats in your computer. Now you got your XC file, you got your XSLX file, which is an Excel file, spreadsheet file. I know this because I've been using Excel quite a lot these days. But yeah, you got the XC file, you got your Word doc, you got the MP4, you got the MP3, you got a JPEG, you got a PNG, you got a WAV. We're dealing with a lot of file formats. Now converting in between those two. No wait, you got assembly, you got a C program, you got a Java program, you got a Python, you got an HTML, you got a PHP. I'm just naming programming languages at the point. And then you got assembly language, you got an ARM architecture, you got a what do you have? You got an x86 architecture, you got an x64 architecture. So you got a C++ architecture, then you got a compiler, you got an object file, you got a link, you got a header file, you got a library. These are many different file formats to access to use this thing in the best way. You got a markdown, you got a markdown format. There are many. But yeah, there are many now converting between those many different file formats best suited for the application that you're using. That is presentation. Lastly, application provides the user with network capable applications. Applications that access the network. So back to my study. Physical data. You got the physical and the data. So you got the physical bit streams, you got the data packets, then you got a network. Or you got a physical, you got data, the data needs to be sent. So you got a physical, you got a connection. What are you gonna do with connections? You got a connection, mechanical thing. What are you gonna do with that? You're gonna send data stream, you're gonna send data in between each data packets. After sending the data packets, you're sending. So data between 1 and 2. Now you need to send to many different things. Now you have a network. Now you send to many different things. And then to ensure that's happening properly, you go to transport. And in transport, I am guessing you have your TCP and your IP protocol. TCP, transmission control protocol, I think. And IP, internet protocol. And you have IP, you have IP4 and IP6. IP4 is all numbers, IP6 is alphanumeric, meaning you have alphabets and numbers. I know too much. Anyway. Got your network, and then you got your transport. Now you got transport. Now you can transport all of this securely. Oh wait, you got HTTPS as well. HTTPS, HTTP Hypertext Transfer Protocol, HTTPS, same thing with security. Right, so you got the transport. Out of the transport, you got the session. I log in, I do my things, I log out. That's my session. After my session, because let's say I log into my session, now I want to access Word, what I've been using for, I don't know why, Excel, or run a program on VS Code. You got your C, you got your Java, you got the C++, you got the PHP, you got your Word. Why are you programming on Word? You got your HTML, you got your CSS, you got your JS, you got your Java, PHP, ASP, .NET, C#, whatever. That's your presentation. And last but not least, you got your application. That is the OSI model. Open Systems Interconnection. I know my things. Funny enough, I don't feel like sitting down. Like I said, sometimes you will fail. No, not fail. You will write the wrong things, not because you didn't study, but because you did not sleep, because you didn't read the question properly. Things happen. So I am going to sleep. That happened in my software actually. I was supposed to get 100 and that happened and I didn't get 100. Anyway. That's just me studying automation. I have a lot more energy. If you enjoyed this, well, comment down below. This is different from my normal persona that I show. So we'll just have to see what happens. We'll just see how it goes and everything. Well, there isn't much. I have a lot of thoughts, a lot of sentiments, but I can't really express it here on the thing. Anyway, comment what you wanna comment. If you have anything to comment down below. For more videos like this, drop down in the link. It's actually pretty easy to make. I just record and then do my things. So if you want to do more, if you want me to go into depth with the things that I went into, then comment, subscribe if you enjoyed. I'm probably gonna release a lot more videos now, like a lot more, because that was my editor. So yeah, and then subscribe, share if you enjoyed this. A different way to study. Studying doesn't have to be all gloomy listening and thing. I do have my fights and things with school because my video's coming out, you'll see it. But yeah, studying doesn't have to be one way. You just set up, make it your own, and roll with that. Regardless, if you like the video, comment down below what you thought, any other thoughts, etc. Share to anyone you think this would be helpful to, and subscribe if you enjoyed this video. Otherwise, I'll see you in the next one.